Hi, everybody. Welcome back. Today, we're going to talk about the mechanisms, fundamental mechanisms of many organic reactions and how you illustrate that in a chemical equation. Uh, the four main ways that electrons move in most organic reactions is the following. You have nucleophilic attack, loss of a leaving group, proton transfer, corresponding to an acid-base reaction, and rearrangements. And we'll look at a number of these in turn with examples. Okay, and we'll see what's going to happen there. So let's first look at nucleophilic attack. When you identify a nucleophilic site and an electrophilic site, a reaction is expected. And where, of course, the flow of electrons is from the nucleophile, the electron-rich species, to the electrophile, the electron-deficient species. And we illustrate that with a curved arrow. The curved arrow reflects the flow of electrons, where the base of the arrow starts at the electrons, and the head of the arrow shows where the electrons are going. In this case, to the carbon, the positive carbon, that's electron deficient. So in this way, a new covalent bond is formed between the carbon and bromine. This is what we mean by nucleophilic attack. Here's another example of nucleophilic attack where you see two arrows. So in the first case, you identify the nucleophile, the alcohol, with the lone pairs of electrons. And then you identify the electrophilic site, which is the carbon of this compound. Remember, an electrophilic site can either be an electron-deficient carbon with 6 electrons, or it could be the positive end of a bond dipole, which is what the case is here. And so the electrons of the nucleophile will form a bond to the electrophilic carbon, indicated by the curved arrow. But a second arrow is required here, of course, because if nothing else happens, this carbon will end up with 5 bonds. And so to avoid that, the pi bond of the C double bond O will break and those electrons in the pi bond will move up to the oxygen as a lone pair of electrons. And that's showed by the second curved arrow, resulting in the product of the reaction where you have a new carbon-oxygen covalent bond and an oxygen with a negative charge and 3 lone pairs. Okay? So the second arrow is simply required so the carbon doesn't end up with 5 bonds. I mean, if it did, there'd be no reaction. So let's look at a second process, a fundamental process in so many organic reactions, which is loss of a leaving group. So in loss of a leaving group, a bond breaks. So and a small molecule or atom departs or is expelled. So in this case, the CBr bond is breaking. And so that's illustrated with a curved arrow, right? The curved arrow shows the flow of electrons, where the electrons in the covalent bond you see are moving onto the bromine, right? The head of the arrow shows where the electrons are going. And so these electrons end on the bromine, so this bond is no longer there. It's broken. You end up with bromide ion with 4 non-bonded pairs. And of course, this carbon now will only have 3 bonds and 6 electrons and will be a positively charged carbon, a carbocation. So this process, which one arrow describes a loss of a leaving group, another very fundamental elementary reaction in organic chemistry. So let's take a look at this example here, a little more complex example at the bottom of the slide. So let's look and take a look what's happening here. So if you look at the reaction, we have hydroxide ion and methyl bromide. And if you look at the products, you see the bromide ion has been expelled. So we've gotten loss of a leaving group. And the hydroxide ion is now attached to the carbon. So we've also got nucleophilic attack. So this process, which is a substitution, an SN2 substitution reaction, involves both nucleophilic attack, illustrated by this arrow, right? So the a lone pair on the oxygen is forming a bond to the electrophilic carbon, and loss of the leaving group, where the bond to the CBr bond is breaking. The covalent bond electrons are breaking and moving on to the bromine, forming bromide ion. So as you see, some reactions can involve more than one fundamental process. So what I'd like you to do at this point is to pause the video and do this activity. And what I'd like you to do is to summarize two of the key features of the following processes. Since we haven't covered proton transfer yet, I'd like you to summarize the key features of both nucleophilic attack and loss of a leaving group, and then include one example for each of the processes using structures and curved arrows to show the electron flow. So take a few minutes to do that, and then when you return, I will review the activity. Thank you.